Welcome. What I want to do today is show you how to simplify this rational expression. So the main important thing when we're simplifying rational expressions is we need to make sure we understand which values that we need to exclude from our simplified answer. And an example of numbers that we can exclude are ones that are going to make this undefined. And one number that would be, or a way that would make this undefined is if I was going to divide by 0. So it's always going to be aware, no matter once I simplify this, or even that term, we need to understand which values are going to make our denominator 0, because that means I'm going to be dividing by 0, which would be undefined. So looking up here, without trying to think of like any kind of number I could think of, what number would make this 0? Well, there is one number that's pretty obvious that's going to make my denominator 0. And if you look at it, these are all multiplied, by n by itself, so it's always going to get larger. However, what if I chose the number 0? Well, 0 cubed is 0 times 9, which is 0. N squared is 0, or 0 squared is 0 times 39 is 0. And 0 times 30 is 0. 0 plus 0 would be 0. So therefore, in my answer, I'm just going to kind of write to the side, n cannot equal 0. So that's going to be a part of my answer once I figured it out. Now, the next thing we need to do is we need to simplify this, right? So when simplifying, what we're trying to do is take out kind of the redundancy of our numerator and denominator. Take out what our terms share in the numerator and denominator. What do they have in common? So I look up here on my numerator, so I'm going to do that first. And I say, all right, what does 21n cubed plus 72n plus 60n share? What do they have in common? Well, you can see they all share that's an n squared. They all share an n. Here is n cubed, here's n squared, and here's an n. So the most amount of n's that they all share is just one n. So I can factor out an n, and then I think about what is the largest number that they all share. Well, 21, 72, and 60, the largest number that divides into all of them that they all share is the number 3. So what I'm going to do is I'm going to factor out a 3n, and I'm just going to kind of do the numerator over here. So when I factor out a 3n, I'm left with a 7n squared plus 24n plus 20. Now you might be looking at this and saying, okay, that's simplified out. But can we simplify it even more? And you're like, ooh, I don't know, right? Well, to do that, to check that out, what we could do is we could see if it's simplified by using factoring. So how do I factor a trinomial that's in this way? Well, there's a couple ways. If you remember, your trinomial is in the form of a quadratic, which is bx plus c, where I can use a little this visionary tool to help me say a times c over b. So a times c is 7 times 20, and then b is 24. Then, to help me factor this out, I can say what two numbers multiply. 7 times 20 is 140. I don't know what I'm thinking. So what two numbers multiply to give me 140, but add to give me 24. So what we want to do is think about all the factors, or numbers that add up to give you 24. Well, or think of the factors of 140, but which one of those add up to give you 24? Well, your answer could be 10 and 14, because 10 times 14 is 140, and they add up to 24. Then what I could do is I could rewrite this as 7n squared plus, instead of writing 24n, I could write 10n plus 14n. Actually, let's not write that in there. Let's just work on this factor right here. Plus 20. And the reason why, and that's going to be a little more difficult, so what I'll do is I'll write it as 14n plus 10n. And you'll see why I did that in a second. So I rewrote that, and now what I can do is factor by grouping. So now, instead of just trying to see what they all share in common, since they don't all share something similar in common, I can try to just factor out the first two terms. And when I had this rearranged to the 10 and the 14 the other way around, it didn't work out the way I wanted it to work out. So I just rearranged those middle terms. So now I look at 7n squared plus 14n. What do those have in common? Well, they have a 7n in common. When I factor out a 7n, I'm left with n plus 2. And then 10n plus 20, what do those have in common? Well, those have a 10 in common. a positive 10 in common. So when I factor out a positive 10, I'm left with n plus 2. Then we go to factor this one more time, and I can see that both of these terms both have an n plus 2 in common. So I can factor out an n plus 2 times 7n plus 10, which is remaining. Whew, okay, so that was the numerator. Now let's do the same thing for our denominator. Let's see if I have a little room. Yes, I do. So a little room for the denominator. Denominator, I'm going to do the same thing. What can I factor out of all three of these terms? And what you notice is I can again factor out a 3n. So I'll factor out a 3n. When I factor out a 3n, I'm left with 3n squared plus 13n plus 10. All right, so now we need to do the exact same thing again. As here, I need to see, can I simplify this further? So I'm going to create my visionary tool, and I'll do a times c over b. A times c would be 3 times 10, which is 30, over 13. So what two numbers multiply to give me 30, but add to give me 13? Well, that's going to be 10 and 3. So I'll do the same thing again. I'm going to do 3n squared, but rather than writing my middle term, I'm going to write 3n plus 10n plus 10. And again, I just rewrote these as I can kind of see. I want to. It's going to be easier that way. So now I'm going to again do factor by grouping. What do 3n squared plus 3n have in common? Well, they both share a 3 and an n. So I'll factor out a 3n, leave me with n plus 1. And then 10n plus 10, what do they have in common? They both have a 10, so I'll factor out a positive 10, leave me with an n plus 1, factor out the n plus 1, and I'm left with a 3n plus 10. Okay, so let's put these all back together. So my numerator, if you remember, was 3n times n plus 2 times 7n plus 10. Right? It was 3n times this, and then I simplified that to down there. Then in my denominator, I have 3n times n plus 1 times 3n plus 10. So again, you notice that if these are all multiplied by each other, right? If n equals 0, that means all of this is going to equal 0. Therefore, n cannot equal 0. But what else, what other possible values for n could I get 0? Because if it's 0, obviously that works. But what about if n was 1? What about if n was 2? What happens if this is 0? And what happens if this is 0? So that's why we write it by using the zero product property. We say 3n equals 0, n plus 1 equals 0, and 3n plus 10 equals 0. Because if each one of these terms was equal to 0, that means the whole denominator would be equal to 0. So what I have here is n equals negative 1 and negative 10. 3n equals negative 10, divide by 3, n equals negative 10 thirds. So what that means is if n equals negative 1, that's equal to 0, meaning the whole denominator is equal to 0. If n equals negative 10 thirds, that's equal to 0, meaning the whole denominator is equal to 0. And if n equals 0, that's 0, and the whole denominator is equal to 0. However, we do notice that 3n and 3n are going to divide by each other. So my final answer is just going to be n plus 2 times 7n plus 10 divided by n plus 1 times 3n plus 10, where n, I'll write this below, n cannot equal negative 1, 0, and negative 10 thirds. There you go, ladies and gentlemen. I know it was a long video. Hopefully you stayed with me. It's a lot of work and a lot of stuff to take a look at. But just remember to always exclude the values that are going to make your denominator 0 when working with a rational term. And then also to factor by using the revert distributive property and also your factoring techniques, which was factoring by grouping, factoring trinomials, and so forth. So there you go. Hope you enjoyed.